Good day everyone, I am Mark Michael de Guzman from BSCE 4C and I am here today to discuss and solve a sample problem for welded connection. So the problem that we'll be solving for this video is this. Determine the design strength and allowable strength of connection shown. Use E70 electrode for the fillet welds and A572 grade 50 for the connecting members. The size of weld is equal to 8 millimeters. As shown in this figure is our welded connection in our problem. We are going to solve for P sub U and P sub A, which are the design strength and allowable strength. For design strength, we are using load and resistance factor design, which or also known as LRFD. And also for allowable strength, we are using allowable stress design or ASD. These are the equations that we'll be using in order to solve the problem here. So first, as I have said earlier, it is for welded connection, so we are using this equation. So for F sub NW, from the equation which is R sub N is equal to F sub NW multiplied by A sub WE. So the F sub NW is equal to 0.60 multiplied by F sub EXX as shown in this table. It is the value of F sub NW. And to solve it, we will use F sub EXX, which is equal to 70 kips per square inch. And in order to convert it in megapascal, we will multiply it using this value, which is 6.895. After multiplying it, we will get 483 megapascal. Now we can substitute the value that we got in this equation. So F sub NW is equal to 0.60 multiplied by 483 megapascal. And we will get 289.8 megapascal. We will be using this value in order to solve our problem. As you can see here, there is our longitudinal and transverse fillet welds equations. So first we will solve for longitudinal fillet welds. So for our F sub NW, we solved earlier, we got 289.8 megapascal. And we will be using this equation from this equation, but only for longitudinal fillet weld. So for the longitudinal, it is equal to F sub NW multiplied by A sub WE, where our F sub NW is equal to 289.8 megapascal, and the value of our A sub WE is equal to 200 millimeters, which is the length of our longitudinal fillet weld here. As you can see in the figure, 200 millimeters multiplied by the length of the throat of the welded area. So the throat, which is 45 degrees, can be solved using this equation. So the throat is equal to cosine 45 degrees multiplied by A. And cosine 45 degrees is equal to 0.707. Now we have 0.707A, and we can now substitute it in the equation. So R sub NWL is equal to F sub NW multiplied by A sub WE will be now uh, R sub NWL is equal to 289.8 megapascal multiplied by 200 millimeters here, and 0.707 from cosine 45 earlier that we solved, and the value of A is 8 millimeters. It is the size of the weld, and multiplied by 2 since there are two longitudinal welds. We will now get 655,643.52 newtons by dividing it by 1000. We will get 655.644 kilonewtons. It is only for our longitudinal fillet welds. So for the transverse, like earlier, we will use the F sub N W is equal to 289.8 megapascal. And like in longitudinal, we will use this equation, but for transverse, we'll substitute the values. We'll now have 289.8 megapascal multiplied by 250 millimeters, which is the length of our transverse weld here, 250 millimeters, multiplied by 0.707, which is cosine 45, multiplied by 8 millimeters, the size of our weld. You will notice that we did not multiply it into 2 because, as you can see here in the figure, it is only welded once. So in R sub NWT, we will get 409,777.2 newtons, and we will convert it into kilonewtons by dividing it by 1000. We will now have 409.78 kilonewtons. Next, using these equations here for longitudinal and transverse fillet welds, we will substitute the values that we got earlier. So for R sub NWL, we have 655.644 kilonewtons, and for R sub NWT, we have 409.78 kilonewtons. We will add them, and we will get 1065.42 kilonewtons for our R sub N. We will now solve for the other equation, which is also R sub N. R sub N is equal to 0.85 multiplied by R sub NWL plus 1.5 times R sub NWT. We will substitute the values, and we will get this equation. Upon solving it, we will get 1171.9674 kilonewtons. As you can see here, in AISC, it is said that total nominal strength of a connection with side and transverse welds is to equal the larger of the values obtained with the following two equations. Since we solved for these equations earlier, these values, we will only evaluate which is the larger value. So this is the larger value for R sub N, so we will be using this one. And now we will be solving the P sub U, which is equal to phi multiplied by R sub N. This is for LRFD. For P sub U is equal to phi multiplied by R sub N. We will have 0.75 multiplied by 117.9674 kilonewtons. This value is the one we solved earlier, and this value of phi came from this one here in the table. As you can see, the value of phi is equal to 0.75. By multiplying it, we will get 878.98 kilonewtons. This is the value of our P sub U. And now for ASD, or our P sub A, it is equal to R sub n over omega. And the value of our omega, as you can see here, is 2.00. So we'll substitute the values, which are 117.9674 kilonewtons, and also it will be divided by 2, which is our omega. So P sub A is equal to 585.98 kilonewtons. These are the values that we are looking for in this problem. Thank you, and I hope you learned something.